I'm Jens, and this is my presentation on disturbing a chemical equilibrium. So a chemical equilibrium is a closed reaction where both the reactants and the products react towards each other with the same rate. And a equilibrium can be described with the equilibrium expression, which shows the relation between the concentrations of the products and the reactants. And if you stress an equilibrium, then the equilibrium expression will briefly be equal to Q, but then it will quickly stabilize and become equal to the equilibrium constant again. And you can also see here how the how an equilibrium is stabilized. With here there's only the reactants, and then the reactants and products start to react towards each other with the same rate. Right, so in the experiment we had an equilibrium between iron plus 3 ions and thiocyanate ions, and they reacted to become iron thiocyanate, which could be seen as a red precipitate. And here's the equilibrium expression for the equilibrium, and you can also see the equilibrium down here in the picture with the reactants here. They react to form the product, and the product reacts to form the reactants again. Right, so I mentioned that the iron thiocyanate ions, they could be seen as a red colored precipitate in the solutions over here. And here in the first test tube we added some iron nitrate to the solution in solid state, and when it came into solution it split up into iron plus 3 ions and nitrate ions. And that of course meant that there were an increase in iron plus 3 ions, which could also be seen down here in the equilibrium expression, where the denominator down here would be increased, and that would mean that the quotient would be decreased compared to the equilibrium constant. And to make up for this, the equilibrium had to react towards the right to create more of the product and use up some of the reactants. And of course this also makes sense if you look at the results over here, where the test tube's solution has a darker red color than the reference test tube, because of the increase in products caused by the shift in equilibrium. Okay, so here in the next test tube we added some ascorbic acid to the solution, and they reacted with the iron plus 3 ions and reduced them to iron plus 2 ions. And of course that meant that there were a decrease in iron plus 3 ions, which also could be seen here in the equilibrium expression. And that meant that the denominator down here would be lowered, resulting in Q becoming higher than the equilibrium constant. And to make up for this, the equilibrium shifted to the left to use up some of the products to create more reactants. And you can also explain this through Le Chatelier's principle, where you take away some of the reactants, and the equilibrium wants to minimize this stress by making more of the reactants. Also, if you look at the results, the test tube or the solution has lost its red color because of the decrease in products, or in iron thiocyanate ions. And here in the third test tube we added some potassium thiocyanate to the solution, which split into potassium ions and thiocyanate ions, which caused an increase in thiocyanate ions and the increase in the equilibrium expression here, and that caused Q to be lower than the equilibrium constant, which meant that the equilibrium would have to shift towards the right and create more products from the reactants, so that this denominator would be lowered and the numerator would be become greater. And you can also see here in the results, the color of the solution is much darker red color than the reference, because of the increase in products after the equilibrium has stabilized. Okay, to the next test tube 4, we added some silver nitrate to the solution, which split up into silver ions and nitrate ions. And the silver ions, they reacted with the thiocyanate ions and created silver thiocyanate in the solid state. And that meant that there were a decrease in thiocyanate ions and the decrease here in the denominator, which caused Q, or the equilibrium quotient, to increase compared to the equilibrium constant. And that resulted in the equilibrium shifting towards the left to create more of the products that were lost here. And you can also see here in the results that the solution has lost its red color because of the decrease in products. And you can also see the white precipitate, and that comes from the solid silver thiocyanate down here in the first reaction. Okay, so at last we have the last two test tubes here, 5A and 5B. In test tube 5A, we cooled the equilibrium solution down, and we saw an increase in red color. And in 5B, we warmed it up and we saw a decrease in red color. And I'd like to explain this through Le Chaillet's principle. So we start with 5A. We cooled it down, which meant that this equilibrium would like to minimize the stress by trying to warm the solution up again. And it would do that through making the exothermic reaction here towards the right. And of course that meant that there were a increase in the product here, the iron thiocyanate ions, meaning that yes, the solution would become darker. And in 5B, we warmed it up, meaning that the equilibrium would like to minimize the stress by cooling down again. And during the endothermic reaction, which meant that there were a decrease here in the products, and of course that the solution would thereby become less red. Okay, so that was the presentation on disturbing a chemical equilibrium. I tried to make it a bit shorter than the previous presentation, but I think this should suffice.